these are our notes over triangle congruence patterns. You should have a foldable. For those of you at home, you can print this. I've attached it to your Google Classroom. The sides fold in. If you want to go back and trim it later, it's really supposed to be trimmed out around this box. But as long as you see all the words on the front side, we're not going to stress out about that too much. So go ahead and fold it. While you're getting folded, I am going to trim mine just a little bit so it looks a little nicer. While we're getting all that folded, wanted to just kind of recap what we've been talking about lately, how it leads into this. Back before fall break, we were talking about translations, rotations, and reflections, just what they were, how to do them, all that stuff. Then after fall break, we talked about how translations, rotations, and reflections are rigid motions, and rigid motions make congruent figures. And we know that they're congruent because all the parts match. So all the corners on the first figure are the same exact measurements as the corners on the second figure. All the lines on the first figure match all the lines on the second figure. They're all the same length. The figures would have the same perimeter. They'd have the same area. They would obviously still be the same shape, you know, triangle and triangle, square and square, and so forth. And so this kind of leads, or well, that leads into this, I should say, because with triangles, you have a limited number of sides and a limited number of angles. And so you can actually know whether triangles are congruent or not without knowing all of those things that we have needed in the past. In the past, we have needed to have congruent angles, congruent sides. I'm not sure if this is screen sharing. I'm sorry. Let's do it this way. In the past, we've needed to have all the sides and all the angles to know whether they match up. Or we've had to know if you could translate or rotate or reflect one on top of the other. And you've needed to have some coordinates so that you could figure out the exact lengths of the lines and things like that. But with triangles, because they have certain numbers of sides and certain numbers of angles inside and certain properties, then these are the shortcuts, some of them are shortcuts, that we can use to prove whether triangles are congruent or not. So on the inside, on this first box over here, the outside says, can I prove that these triangles are congruent? So the first thing I want us to focus on is this word prove. So I'm going to kind of box this in on the outside. You can highlight it if you would like. And on the inside, we're going to write that prove means that you can be 100% certain. So prove means to be 100% sure. We'll put sure instead of certain because it fits better on my line. And you could be sure whether the figures are or whether they are not congruent. So prove means to be 100% sure that something is or is not true. And in our case, that would mean figures are or are not. I'm going to go ahead and put my congruent symbol under there. Keep it all on one line. So some of the abbreviations and the shortcuts on this page, these congruence theorems, are actually used to prove whether or not triangles are congruent. Some of them cannot be used to prove triangles are congruent. Now, don't mistake that to think that it means that if you have those patterns, the triangles are automatically not congruent. That's not the case. It means you can't prove it. You can't be 100% sure that they are or that they are not. You just don't have enough information on those certain patterns. So at first we cover the patterns. I cover the patterns that are not going to work. And so I usually slide down to the bottom. I'm going down here to angle, angle, angle. So on the outside, I'm going to put not necessarily. If you have two triangles and all three of their angles match, that does not necessarily mean that they're congruent. The example that I typically use with this is an equilateral triangle. You can have equilateral triangles that are really tiny and equilateral triangles that are really huge. All of them have 60-degree angles on all three corners, but that doesn't mean all the triangles are the same size. So just because you have angles that are the same, that does not necessarily mean that they're going to be congruent. On the inside, we're going to put a little bullet point. We're going to put AAA, because we do abbreviate these with just the first three letters. So angle, 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 or AA. We'll talk about why you can do either one in just a second. Proves similarity only. And then we're going to put another bullet. We're going to say, think about equilateral triangles. All have three 60-degree angles, but not all triangles are congruent. So on this first line, I put angle, 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 which is on the outside of the page, or angle, angle, only two A's instead of three, two angles instead of three. If you have two angles of a triangle, you really do know the third one, because all the degrees in a triangle, or sorry, all the angles in a triangle are supposed to add up to how many degrees? Good, 180. So if I know two of those angles, I can subtract from 180 to find the third. Even if I don't have numbers for those two, if I know they match each other, there's still only one number that exists that's going to make the total 180. So it has to be the same in both triangles. So you'll see it written both ways. Three angles, two angles, AAA, AA. They're both exactly the same thing. And that only proves similarity. Once again, with equilateral triangles, these two triangles right here are similar. You have three different sets of corresponding angles. This one is the same size as this one. This one at the top is the same size as this one at the top. And this one down here is the same size as this one over here. But you can see that the triangles are clearly not congruent. They're clearly not the same size as well. So we don't have anything on that triangle to give us a size. And that's really why we can't prove anything. We just know that they're proportionate to each other, not what size they each are. On the other side over here, side-side angle, this is another one that's not necessarily So again, sometimes they might be congruent, sometimes they might not be congruent. You don't know for sure. You don't have enough information. So side-side angle, when we look at the inside.
Destiny Floyd, come to the front office. Destiny Floyd, come to the front office.
When we look at this on the inside, you can kind of see that you have this opposite side and angle thing going on. And this is one of the reasons that you don't have enough information. It's going to make a whole lot more sense after we go through some of the other ones. But I do want to pause and just kind of say over here, always use or write SSA, not in reverse. Okay, we're not going to reverse that. And I think you can see why. Miss Babbitt says, no booties on the paper. Let's put parentheses around that. So these patterns that we're going to read, they have to go in the shortest path possible. The shortest path is going to have the fewest number of blank spots. A blank spot could be a side, or a blank spot could be an angle, but it's just any spot on the triangle where you don't have a measurement either given or marked. So you would have side, side, and angle. And the shortest path is going to have the fewest empty places. So up here in the top, this is an empty place. Can you see that? It's a question mark. Just put a question mark right there. Let me get a different color and do that. We don't know anything about that. We also don't know anything about this one, and we don't know anything about that side. Those are our gaps. So when we start reading our letters in order, we need to have as few gaps as possible, or as few of those question marks as possible. So the way to do that is either to start here and go A, S, S, and then, oh, no booties on the paper. Let's do that in reverse instead. So then you go over here and go, okay, S, S, A. That's a little more PG. So a little more school appropriate. So the shortest path is like that, because in this path, you only have, you just got it, didn't you? That's okay. I appreciate that you got it. So the shortest path only has this one question mark up here. Let's see what would happen if we tried to read it another way. Maybe S-A-S. That's going to be another pattern, and that would prove congruent. So I would be looking perhaps to try to get an S-A-S out of this. Well, if I try to do S-A-S around that way, notice I've got two question marks. I don't want two if my other path only has one. Take the shortest path around your figure. And that's something that we're going to write down here in the bottom. This goes for every postulate that we have, or every theorem. Always read your marks in the shortest path. Always read your marks in the shortest path. Some of these are going to have the same combinations of letters. For example, 2 S's and 1 A, 2 A's and 1 S. And knowing which is which is going to come from reading them in the shortest path. And if you don't know which is which, you're going to mess up and get some wrong answers from time to time. So always read your marks in the shortest path. And if you're still not super clear on that, let's go ahead and just write out to the side. No more than one gap allowed. Ever. Any postulate. So even over here on our angles, our gaps are the sides. So you have, there's an angle, and then there's a gap, and then there's an angle. And so my gaps are kind of over. I've wiped them out, wiped my slate clean. There's another gap, but there's another angle, so I've wiped that slate clean again. And then there's another gap, and I'm right back to where I started. So you don't want your gaps to build up. Over here, again, if I tried to read it the other way, I would have 2 gaps built up, and I can't have any more than 1. 1 is allowed, a group of 2 is not. So these are the 2 that do not necessarily prove that shapes are congruent, or that triangles are congruent, because you just don't have enough information. Some of the triangles might be, sometimes they might not be, but you can't prove it with just this combination of information. Now we're going to go back up to the top, and we're going to talk about side, side, side. If you have 2 triangles and all the sides are the same size, are those triangles going to be congruent? Yeah, you can pretty well guess that. That one's one that you probably don't really need me to explain to you. So this is a for sure yes. You can prove one way or the other if triangles are congruent if you have all of the side measurements for the different triangles. If they match, you're sure that they're congruent. If they don't match, you're still sure, but you're sure that they're not congruent. Because remember, proving, you could prove something true or you could prove it false. If you have this information, you are able to prove whether they do match or whether they don't. So side, side, side looks like this. You just have all 3 marks. Like I said, this one's kind of the no-brainer. So all we're going to write up here is if all 3 sides do match. The triangles are congruent. Side, side, side. If they don't match, the triangles aren't congruent. And that kind of logic goes for each of the other triangle congruence postulates as well. Just because you have the pattern doesn't mean they are congruent. It means you can prove that they are or that they are not. So let's look down here at this one. This one is angle, side, angle. You can prove with angle, side, angle. You can prove that they are, or you can prove that they are not. Angle, side, angle is enough information, and let's look at why. I said at the bottom of this column that if you have two angles, you really know the third one because you can just subtract from 180. And at the bottom, we said that the angles alone were not enough to prove congruence because it didn't tell us what size the two triangles are. But here, we have a matching side in a matching place that tells us that the triangles are the same size. If all of these angles open up at the same amount, you know, all three angles, both triangles, and one of the lines is the same, that means all of them are going to have to be the same. Because if these angles open a set amount, there's only so long the opposite side could be, all the way around the figure. So that is angle, side, angle. And your question marks, your gaps are here and here and here. So when you're reading this, your path with the fewest gaps is just straight across that one side, just like that. Same thing on your other triangle. You have this angle, you have this side, you have this angle, and then you have all these gaps up here. So your shortest path, once again, just goes straight across that side. Angle, side, angle is going to be one side and the two angles on each end. That's another way that you can kind of visually tell if it's the angle, side, angle pattern, as opposed to a different one like angle, angle, side that has the same number of A's and the same number of S's. This is only one side. So it's one side of the triangle and then the two angles that it runs into. So you got the shortest path method, and then you've got this other little reminder over here on how to identify that. Along with angle, side, angle, I've used side, angle, side, and I kind of put those together. This is another yes. You can see side followed by angle followed by side. Same thing over here, side, angle, side. And your shortest path, in this case, has no gaps. All of your gaps are here, and here, and here. So your shortest gap over, or your shortest path over here has no gaps. Your shortest path over here has no gaps. This one is one side and the angles on each end. This one is one angle and the sides that make that angle. So we're going to write that over here. One angle and the two sides that meet there. So again, you've got the gap thing. That helps you on all of them. These two in particular have some extra descriptions as well. Now, because of the way these are set up, I call these the sandwich patterns. Let me. And it's both of these, right? SAS, ASA. The letters kind of make a sandwich. So on this side, your S's, that's your bread, and the A is in the middle. Over here, your A's are on the outside, that's your bread, the S is in the middle. When you make a sandwich, let's think about a turkey sandwich. You have a piece of bread. At the very least, you have to put a slice of turkey on there. So we're just going to go with the most basic sandwich you can make, bread, turkey, bread. When you make a sandwich, none of your pieces magically hover above the other pieces. When you put down a piece of bread, the turkey has to touch it. And then when you put down that other piece of bread, it has to touch the turkey. All of your pieces touch. So the sandwich patterns are where all the pieces touch, and you have no gaps. In the pattern. All the pieces touch, there are no gaps in the pattern. Just like when you make a sandwich. I would really hope that if you make a sandwich and your last piece of bread hovers above the top and there's a gap of air in between your turkey and your bread, that's some really ripe turkey and you need to get rid of that sandwich. That is not a good sandwich. So make yourself a good sandwich with SAS and with ASA. And a good sandwich has all the pieces that touch. So you really kind of have three different ways to remember how to identify these two particular patterns. And that's kind of nice because when you slide down here, this one has two A's and an S also. So let's look and see how this one is different. There's an angle, and there's a side. And then let's look at our gaps. Now you're not always going to go through and write these question marks in there. But as we're learning it, I feel like it's helpful so that you have a visual to see where the gaps are. These are your gaps in information. You know nothing about those where we have a question mark. So the path with the fewest gaps goes across the bottom and then kind of curves around this way. Now, don't get too hung up on going across the bottom per se because your triangle might at some point be turned differently, but again, you have the fewest gaps. This path would have only one question mark. If I tried to go up and curve down, then I would have two question marks and we can't do that. We're only allowed to have one at a time. Okay. So we're just going to put another little reminder over here. Remember, no more than one gap at a time. Okay. And your gaps are your question marks. So being able to read it in the shortest path is really the only thing that's going to help you determine whether you've got angle, angle, side, or angle, side, angle. That's why I've been stressing how to do the path with the shortest number of gaps in it, and why I went over the stuff about the sandwich, because both of them prove that they're congruent. But sometimes the question is just, what theorem lets you know that they're congruent? And if you can't tell the difference between ASA and AAS, you're going to have a hard time. So read it in the shortest path. Let's go ahead on the outside and put a yes out here, because angle, angle, side can prove. It can prove whether they are congruent. It can prove whether they are not congruent, but it can prove. And then our last one over here, this is hypotenuse leg, and this is going to be another yes. But what kind of a triangle must we have if we're talking about a hypotenuse? Yep, right triangle only. So in parentheses down here, only used on right triangles. Okay, only used on right triangles. Now, does that mean that I can't use side, side, side for a right triangle? No, I can still use all of those other ones, but because a right triangle has some special properties, this is an extra way that we can prove that these are or are not congruent. So hypotenuse leg, we're going to put up here, works based on Pythagorean theorem. And I'm just going to put a squared plus b squared equals c squared, because that's shorter to write than Pythagorean theorem. So basically what happens is, if you know you've got a right triangle, any two sides is all you need to know how long the third side is. It's kind of like having two angles in a triangle. If you've got two, you can figure out the third. Well, the same is true in right triangles for the side lengths. If you've got two, you could figure out the third. So technically, it's like side, side, side. But you just don't actually know the third side. You would have to figure it out on your own. Okay? So we're going to put HL can only be used on right triangles. And then we're going to put right triangles can also use all other congruence theorems. So just to make it extra clear that we're not saying if it's a right triangle, it's hypotenuse leg or nothing. You can still have a right triangle that uses angle, side, angle, or a right triangle that uses side, angle, side. But you also have this extra option that only works for right triangles, because Pythagorean theorem will tell us how long the third leg is. And that's pretty much it. Just to kind of review, we have a couple that can't be used to prove anything. Angle, angle can prove similarity, but because it doesn't give us a size as well, we can't use it to prove whether things are congruent or not. So even if you have three perfect, you have angles that match perfectly from one triangle to the next, you're still not sure that they're the same size triangle. You're sure that they're similar, but not congruent. On these other ones, these two that have two angles, we could find the third angle, and then we have a side somewhere that gives us that extra information that we were missing down here. So these three, they kind of all go together. And in a sense, this one goes with it, because if you have three matching sides, there's only one combination of angles that's going to make those three sides match up just like they do on the corners. An angle that's too small or too big would make your triangle's sides like have gaps in between them or overlap each other instead of meeting up perfectly at this corner. Over here, you have some different cases. Because you have two sides that are the same and the angle in between them, or sorry, these two sides are not the same. Because you have two sides that are given, you know that there's a range that this third side could fall into. We talked about that a couple months ago. You just add and subtract these two numbers, and that gives you the possible range for this third side. Well, then you have the angle opening, and that lets you know exactly how long this is going to be. It's a little bit more complicated math to find that out, but it can be done. Same thing over here. If you have matching pairs of sides, and the angle in between also matches, you'll know that this side is going to have to match this side. Then down here on hypotenuse leg, basically, because you've got Pythagorean theorem, you could find the third side, and then you would know that they're exactly the same. So instead of actually doing that, we're just going to go, oh, yep, if these two match, that other one's going to match too. And that's why some of those work and the others don't. So let's look at your IXLs. You have 3 IXLs today, but they're really not long. Let's see. Okay, so we've got side, 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 and side, angle, side. Those are our first ones. They're broken down into just 2 as opposed to putting them all mixed in together. We'll mix them all up tomorrow. So for today, you've just got 2 to work with. And you really don't even have to tell which is which. They're just kind of getting you used to seeing the patterns. So side, 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 and side angle side, there's only one level. When my teacher account loads, you'll see there's only one level to this skill. I can't jump. So that's pretty good. And the question is always, which 2 are congruent by, and then it's going to tell you. It's either going to be side, angle, side, or it's going to be side, side, side on this one IXL. So you just have to look at your marks carefully. A really important part of this skill that is really easy to kind of gloss over is the details. Everything hinges on you paying attention to the details for these marks. You don't have numbers. You just have these little marks. So if you don't pay attention to which ones actually do match and which ones actually don't, then you're going to make it harder than it really is. Okay, it's not like a work of art where you can look at it and be like, oh, that's the Mona Lisa. It's more like a book where you have to read all the words that are in the page to get the big idea. So I usually start, just pick a place, but I usually start with the smallest number of markings. That's just me. I see a 1 over here. I see no 1s. So those 2 don't match. I also see no 1s over here. So it's got to be these 2 that match each other. So just to verify, I've got 2 marks, a 1 mark angle, 3 marks. 2 marks, a 1 mark angle, 3 marks. So those do match. Now, when you make your congruent statement, remember that your letters have to go in matching order. Any order is fine as long as they match from one triangle name to the next. So you don't have to put ABC, and ABC doesn't have to go in the first blank. I'm going to do TUS right there, and then we're just going to make this second one match. So from T to U goes down the side with 2 marks over to the marked angle, and then keep going. Here's my 2 marked side, here's my marked angle. So that must match CAB. There you go. You just keep on going. Find the 2 that match according to side, side, side. You got to fine tune the details. See which ones actually do match and which ones don't. Make your congruent statements. ASA and AAS, these are going to be basically the same thing, but you got to look at the details, make sure that your angles and your sides actually are matching. Do not do this visually. Okay. Now, in this case, they are kind of drawn to scale, but on other exercises, they might not be. So when I'm looking at it, I'm going, well, this one clearly looks bigger than these 2, but please still check it with the marks. 2 mark angle, 2 mark side, 1 mark side. 2 mark angle, 2 mark side, 1 mark side, and then just make your statement. So WUV is what I'm going to put, and that's no marks to 1 mark to 2 marks. So that's going to go TSR. And that could literally have been any combination of those letters. Doesn't matter which triangle is first. So don't freak out about, am I doing the first one right? The first one you get to pick, and the second one you just make it match. Notice again, only 1 level. Now the third one is you're gonna need a little bit of paper. This is hypotenuse leg. It's only 1 theorem. They're always gonna give you a hypotenuse and a leg, but the question is basically gonna be, what value makes the triangles congruent? So you just have to set the matching sides equal to each other. So at the beginning, right, you have the hypotenuse as V, and you have the hypotenuse as 47. So what's V gonna equal? 47, yeah, should just be 47. The hypotenuse over here and the hypotenuse over here have to match. Then we have a long leg that's 44, and then we have a long leg that's W, so W must equal 44. Pretty easy. Now, if you're not sure, please use the congruent statement. It's up there for a reason. On other problems that's not the very first one on the very first level, you might need it. Now you start seeing a little bit of variables with some numbers in front. So like 5C equals 15. Just write it down and solve it. 5C equals 15. So 5 times what is 15? 3. So C must be 3. And then B is going to equal what?
47.
There you go. Now, I'm going to go ahead and skip up to like the highest level. Notice you just have some, you know, B plus 47, C plus 7. It's not super hard. I think this is the last. No, it's really pretty much the same thing. The equations just get a little more involved as you go up. Okay, so up at the very topmost levels in the challenge zone, you have 2 variables. So you have to look and see which one you can solve for first. So our hypotenuse over here is 11b. Our hypotenuse over here is 12b minus 9. If you've only got one variable in your equation, you can solve for it. So solve for that first. 12b minus 9 equals 11b. So b equals 9. It's okay if you can't do that in your head. I do math a lot. So then I can take 9 and plug that in everywhere I see b on my other expressions. So now instead of 2c plus b plus 8, I have 2c plus 9 plus 8, or 2c plus 17. And that's a little bit easier to solve. Instead of 3b plus c, I have 3 times 9 plus c, or 27 plus c. And then you can solve it that way. All of these in the challenge zone, once you get up to 90, if you're shooting for 100, shooting for some extra credit, just find the one that you can solve first, and then you'll plug that answer into your other expressions. All right, so any questions about any of that? You get to pick, so it doesn't matter. If you did, okay, so just make sure that your parts match up. So like, let me do this one. I've got 1 mark, 4 marks, 3 marks, 1 mark, 4 marks, 3 marks. So these 2 on the outside are the ones that match. So you could do IJK, but you could do KIJ also, just from K to I to J. And then you just have to make a matching pattern over here, but the pattern goes by these marks on the triangle. So from K to I goes down the side with 4 marks, and then down the side with 1 mark. So over here, I'm going to go down the side with 4 and then down the side with 1. So that's S to R to Q over there. Okay, so over here, we've got 2 mark side, angle, 3 mark side, 2 mark side, angle, 3 mark side. So this one could be YXW. It could be YXW, it could be WYX, XWY, any number of things. There's like 8 different combinations that you could do. Over here, I just have to make it match. So if my Y is on the end, the unmarked end of my side with 3 little red lines, I'm gonna go find that over here. So here's my 3 little red lines. The unmarked side is E. So my first letter is E. And then X is my marked angle. So I'm gonna use my marked angle next. So E and then F. And then the last one just has to be the third one. So that ended up being alphabetical, but that's just a coincidence. Okay. Any others? All right, thank you for asking. All right, so let me end this real quick. Folks at home, if you have any questions, please email.